Hello friends, welcome to the session on data structure. In this session, we will be discussing about certain operations on the linked list, such as traversing operation and searching operation in the linked list. Friends, as you know that whenever you want to implement the other data structures, such as queue, then you will find that the queue data structure can be implemented by making the use of the linked list. So linked list is a very useful data structure. In arrays, we require successive or sequential memory locations. But if the size of the elements is very large, then in that case formation of the array becomes difficult. And in such a case, we can go for the use of the data structure called as a linked list. So friends, in this session we will see how it is possible to write the algorithms to perform certain operations on the linked list. So let us start the session and let us understand how it is possible to write algorithm to perform traversing operation on the linked list. Friends, as you know that whenever we have been given a set of array, then the array requires the successive memory locations, and therefore they require a large memory space, particularly when the number of elements in the array are large. And the size of the array is also fixed, and whenever we want to perform any operation such as insertion or deletion in the array, then it is very difficult to perform, because if you want to delete the element which is in the middle of the array or which is at the end of the array, or if you want to insert the element which in between the two elements of the array, then the operation requires large number of steps. And these problems that are associated with the arrays can be resolved by making the use of the linked list. Linked list, as we know, is a collection of nodes, and these collection of nodes basically consist of two things. The first one is being called as a data and another is being called as a pointer. So every data element in the linked list will have a pointer, and that pointer will point to the next element. So as shown in this diagram, one can easily observe that linked list is basically a collection of nodes, and where there is some data value, there is some pointer value. So it is not necessary that whenever we form the linked list, we should have been given the successive memory locations. We can form the linked list in any part of the memory, and it is possible that giving the proper pointer address or memory address, we can connect all the nodes of the linked list together. Now, whenever we have been given any linked list, then it is possible that we can perform the operations such as traversing. Traversing operation means we will visit each and every element of the linked list. We can perform the operation such as insertion, where we can add any new element into the linked list. We can perform the operation like deletion, where we will remove the existing element from the linked list. And whenever we have been given some key element, then we can search whether that key element is present in the linked list or not. As far as this session is concerned, we will see how it is possible to traverse each and every element of the linked list, and this operation is being called as a traversing operation. So traversing operation, you can say, it is a very fundamental operation of the linked list, because frequently we need to perform such type of the operation where we will visit each and every node of the linked list. Now let us see how it is possible to visit each and every element of the linked list. The first thing or the first step that we will do is that we will initialize a temporary pointer to the head node of the singly linked list. Suppose we have been given a simple linked list or a singly linked list, then what we will do is that we will initialize a pointer to the head node, and then we will check if that pointer is null, because if the list is not containing any element, then you will find that the head pointer itself will have a null value. In that case, we will return or we will not process further, because there are no elements in the linked list. But if it is not null, then in that case it means that there are elements present in the linked list, and therefore we can visit now each and every element of the linked list. When the pointer is not null, then we will access, and we can, if you want, then we can print the data element of the current node. And we know that the current node will have an address of the next element, therefore we will move the pointer to the next node. and this process we need to repeat until we visit to the last element of the linked list. Now, as I said that whenever we have been given a linked list, it is frequently needed that we want to search for a particular element in the linked list. If we want to search for a particular element, then we have been given a linked list and we must know what is the value of the search element. Suppose the search element is being called as a key element, and now we can search whether the key is present in the linked list or not. Now we can write the steps of the algorithm as shown in this window. Now you will find that initially we will initialize the node pointer where current is equal to head. Suppose our pointer is current and this is being pointed or this is being initialized to the value of the head pointer, and then we will repeat these steps while the current is not equal to null. And because we know that whenever we reach the last element of the linked list, then the last element of the linked list is null, and therefore the current value will become null. So when the current value will become null, it means that we are at the end of the linked list. Therefore we will repeat the step of the searching until the current is not equal to null. So we will check if the current value, that is current, is equal to the key. We will check the value of the current whether it is equal to the key, and if it is equal to the key value, then the element that is being pointed by the current, if it is holding some value and if that value matches with our key value, then we will announce the successful searching of the element. And if it is not, then in that case what we will do is that we will point to the next element, and the next element can be pointed by making the value of the current equal to the next element. So in this way you will find that repeatedly we go on visiting each and every element of the linked list in order to search whether a particular element is present in the linked list or not. So as discussed in this algorithm, you will find that if the key element is being found, we will announce the successful completion of parsing. If the key element is not found, then we will announce that the element is not present in the linked list. So this is a very simple algorithm. Initially you must have a pointer that is being assigned with a head value. Then we will check the first element value and the element that is being pointed by a current or a key value, and then if the values are matched, then it is okay, you will announce the successful searching. But if their values do not match, then what we will do is that we will increase the current, or we will increment the current pointer in such a way that it will point to the next element. This process goes on until we reach to the end of the linked list, where the end of the linked list is being marked by a pointer value equal to null. So this loop is being repeated until the current is equal to null. As soon as current becomes equal to null, and if the search is not done, means if the element is not found, we will announce the unsuccessful completion of searching. Otherwise, we can announce the successful completion of searching. So thank you friends for viewing the session. Hopefully you have understood both of these algorithms, traversing a linked list and how to search an element in the given linked list. Thank you all.